Okay, so we're here with our Period 1 class. We have 2 more lessons before we finish all the lessons for this unit, and then we'll start reviewing for our test, not this Thursday, but next Thursday. We'll have a test next Thursday. So today is all about exponents. So let's go ahead and review some vocab here so we know what we're talking about. So if I have a raised to the exponent of n, or the power of n, the base is always going to be that larger number. The base is always going to be the larger number. All right, and the exponent, all right, because I don't want to raise to a power of e, because e actually means something in math, and that would it'll confuse me more than you, but I don't want anyone to read and be like, whoa, why are you raising the power of e, because that means something. But a to the n means nothing, right? A can be any number or variable, and n can also be any number or variable as well. Okay? Any questions on base and exponent? Hopefully these words seem familiar to you. Okay, great. So there are some properties that I want to go through. Before we get into exactly what these properties are, I wanted to show you something about exponents that I think is really going to help our understanding before we really dive into it. So go ahead and flip your paper over. And you see the kind of the blank space under there? Draw a number line somewhere under there. Draw a number line somewhere in that blank space. In the middle, I want you to put 0. And we're just going to move to the right 3 and to the left 3. So you'll notice we're going to positive 3 and to negative 3. But what's different about this number line is this number line, all of these numbers, I want you to think of them as exponents. Okay? So that's not just our typical numbers, 0, 1, 2, 3, and negative 1, 2, 3. This is, I want you to think of those as exponents. Okay? So I'm going to give you a base, and we're going to take those exponents, all right, and that's going to be the exponent on the base that I use. And I'm just going to use the base of 3. So the first one will be 3 to the 0, then 3 to the first power, then 3 to the second power, then 3 cubed, 3 to the negative first power. And it could have been any base. I chose 3, but any number you want. And I want to start on the right side, because I think most of us are pretty confident as we move to the right. What is 3 to the first power? It's 3. What is 3 to the second power? 9. What is 3 to the third power? 27. You multiply by another 3. So every time we moved to the right, we were multiplying by 3. Everyone see that? Now, do you know what 3 to the 0 power is? It's not 0. It's 1. And that's one of our properties that's on that slide on the other page. All right? It's called the 0 exponent property. Anything to the 0 power is 1. Now, you may be wondering, how does that work? Well, let's think about this. How did we move when we moved to the right? What did we do to get these numbers? We multiply by 3. So if I move to the left, what is the opposite of multiplying by 3? Dividing by 3. So what is 3 divided by 3? It's 1. So that's why anything to the 0 power is always 1. Now watch this. If we're going to divide by 3, going to the left, all right, so I'm going here, going here, going here. I'm going to divide by 3 now. What does that mean 3 to the negative first power is? What's 1 divided by 3? Not 3. What's 1 divided by 3? It is 0.3 repeating. Let's keep it in fraction form. What's 1 divided by 3? It's 1/3. 1 divided by 3 is 1/3. What about another divided by 3? 1/3 divided by 3. Somebody said it. 1/9. 3 times 3 is 9. Katya, what did your brain just see? And it's the same numbers as these, right? So it's going to be 1 over 27. Now there's another property that we're going to talk about that says when you raise something to a negative power, it's 1 over that, and you change the power to a positive. It looks like this. A to the negative n is equal 1 over a to a positive n. So you put it in the denominator. The reason I wanted to do this number line is because when I do these properties, some students just are still struggling with what does it really mean to do all this. And if you understand that when you move to the right, you're multiplying by 3, and you move to the left, you're dividing by 3, you can do any of these. All right? So that's why hopefully doing this, you feel more confident with those negative exponents. Any questions on this number line? Okay, you guys understand more about exponents than most adults do now. All right, so that's awesome. Good job. Okay, so now with that understanding, let's flip your paper back over. Flip your paper back over if you haven't already. And you'll see these two properties that we just discussed. Okay? Now there's one kind of, you can see here the one that I went over with the negative exponent property. But there's one interesting one that doesn't get a lot of love. I'm going to give it some love. And it's this one here. Does everyone see that one? You see how it's a fraction raised to a negative exponent? See how it's a fraction to a negative exponent? Fraction, negative exponent. How does it change when you see on the other side? It's a reciprocal. And what happens to the exponent? Exactly. So most students don't know that one, and it will save you so much time when you're evaluating these. Okay? So most of the time when you think of the negative exponent property, you're thinking of the ones up top. All right? Where you have a whole number base to a negative exponent, 1 over that whole number base to a positive exponent. But that fraction one is going to save us a lot of time if you know it. Okay? All right. Let's do some examples. What's the answer to 1, 2, 3, and 4? 1. Look at that.
Is it always positive 1?
Is it always positive 1?
Yes.
Yes. Anything to the 0 power is 1 every time, right? Just like we're all going to die. We all have to pay taxes. All right? Anything to the 0 power is 1. All right? That'll be on my headstone. Okay. Let's take a look at 5, 6, 7, and 8 because it gets a little more challenging here. We already went over 3 to the negative 2nd power, so I'm going to skip that one. But let's look at 2 to the negative 6th power. All right? If you're going to use the property, that's 1 over 2 to the positive 6th power. All right? Now this might be a little tough if you don't know your powers. Do you know what 2 to the 1st power is? It's 2. What's 2 squared? What's 2 cubed? 8, right? As you multiply by another 2. What's 2 to the 4th power? 16. 2 to the 5th power? 2 to the 6th power? Very good. So it's 1 over 64. I hope that was on the recording. One of my professors in college for business law, she would do that before every lecture. She'd come in and like pop her neck like really loudly. And then she'd be like, okay, I'm ready to go. Like, this one, her name was Margot. She was intense. Oh man, she was intense. Okay. Woo! Scary. Okay. 5/3. She was like a tiny little woman, but man, she was fiery. 5/3 to the negative 2nd power. So this is the one I was talking about. This is what I was talking about. Where if you know that, it's going to help you so much. This is a fraction, 5 over 3. Let's rewrite it. 5 over 3 to the negative 2nd power. So when I simplify this, I want that negative exponent to be positive 2. And in order to do that, I need to use the reciprocal. Now, I know it's been a while since you've done this exponents and fractions, things like this, because this is probably early on in Algebra 1, 2 years ago. But there's a couple ways to look at a fraction squared, a fraction to a power. All right, you could write 3/5 times 3/5. right? Because that's what it means to square something. You multiply it by that same thing again. All right? Or you could think, what is 3 squared? 9. And what is 5 squared? And that's what the answer is going to be. I prefer the second way, right? You can see again, if you multiply across, 3 times 3 is 9. 5 times 5 is 25. The reason I like the second way of using the powers is because what if that power is to the 5th power? Right? And then you're going to have to write it out 5 times. You don't want to do that. Okay? So just think each part of the fraction, the numerator and the denominator, is going to get raised to that power. Questions, Zach? No? Okay, sorry. Feeling cooler? And then what about for number 8? We don't have a whole number base. We have a letter base. That's going to be 1 over m to the positive 8th power. 1 over m to the positive 8th power. Questions on the 0 exponent property and the negative exponent property? Yes, so all you do is you take this m to the negative 8, you move it to the denominator. All right, we put it underneath a 1, and we make sure the exponent becomes a positive. And that's something that's going to help you always today and whenever you look at exponents. If you've got a negative exponent, move it across the fraction bar and make it a positive. Yes, Ashley. Well, so the m has the negative 8 to start, right? So it's saying m to the negative 8th power, so the m's got to keep the 8. But if we move it to the denominator, we can change that exponent to be a positive. Okay? Okay. Skip that one. Okay, now, oh my gosh. Whoa. Whoa. That's a lot of properties. But, lucky for us, you've already done all of these. Okay? Take a quick peek at some of these over here. Key thing I want to point out is when you're multiplying with the same base, what happens to the exponents? You add them. All right? So if you're multiplying with the same base, the exponents add. That's something you need to remember. If you are dividing with the same base, the exponents subtract. This is a good one that students forget what to do. A power raised to a power. Power to a power is multiply. Power to a power is multiply. Probably won't use this one much, all right, because most students will just do the parentheses first and then square it. All right, but this says you can break it up and they each get the power. And then I just talked about this one on the last slide. Okay, let's use them. You don't need to know the names, just how to use them. Okay, let's try this first one. This is 3z to the 7th power times negative 4z squared. First thing I notice is that there are two numbers, two coefficients, 3 and negative 4. What is 3 times negative 4? Negative 12. So I know I'm going to have a negative 12 in my answer. Then I see z to the 7th power times z squared. So if I do a little work over here, that's z to the 7th times z squared. This is multiplying with the same base. Multiplying with the same base. So what am I going to do to the exponents 7 and 2? You're going to add them and get z to the 9th power. Questions? Not yet. I love it. Question? Okay. Now, the next one. The next one has a fraction, yz cubed in the numerator, and then c to the 5th power in the denominator. And it says, take all of that and cube it. All right? Now you have options here. You can simplify inside the parentheses, because I see two instances of the same base. Or you can raise everything to the 3rd power first and then simplify. Do I care? No. All right, I've been doing this for a long time. The students that I see with the most success simplify inside first. Okay? So let's simplify inside first. So we have y is going nowhere, because there's no other y. Here's how I always tell students to think about it when you have the same base in the top and the bottom. Okay? Which one has more z's? The bottom, right? Because 5 is bigger than 3. How much bigger is 5 than 3? 2. So it's over z squared. Because what your Algebra 1 teacher, or maybe even your pre-algebra teacher might have taught you is to do subtraction there. I just find students have trouble with the subtraction and where is it negative, positive, blah, blah, blah. So just ask yourself those 2 questions. Which one has more, top or bottom? How many more? Done. Okay? Now, all of that still needs to be raised to what power? The third power. And now we have powers being raised to a power. So each of these, numerator and denominator, it needs to be cubed. Now, there's no exponent with y, but what is the exponent with y? It's a 1. So there's an imaginary 1 right there. So what am I going to do with these powers when I raise them to the third power? Very good. When I go to bed at night, I say my prayers and I say power to a power is multiply. Power to a power is multiply. So the answer is going to be y cubed over z to the 6th power. Questions on that one? Yes. Go ahead, Ariana. So you're saying if it would have been y z to the 5th power over z cubed, then you see my first parentheses? This parentheses would have said just y times z squared with no denominator. All right, so you don't need to have a denominator if there's nothing in it. All right, good question. Let's do the next one. 5x to the 6th power, all of that cubed. Now, most students at this point feel confident on what to do with x to the 6th power cubed. That's another power to a power, so what do? You multiply, and you get x to the 18th power. But what I see every year is students struggle with this coefficient. Is that coefficient in the parentheses? Yes. So it also needs to be cubed. I get a lot of students that write 15 here because 5 times 3 is 15. But it's not, you don't do that with a coefficient. You only do that with powers when you multiply for power of a power. This is a 5. So that's 5 times 5 times another 5. So what's 5 cubed? It is 125. So just keep that in the back of your mind when it shows up. If you've got a coefficient that's being raised to a power, treat that normally, how you would before you learned about exponents for variables. Okay, the next one. 2x cubed times negative 5x. This seems a lot like the first one we did. I see 2 coefficients, 2 and negative 5. What is 2 times negative 5? Negative 10. And then I have multiplying x cubed times x. Showed a little work over here. X cubed times x. So what am I going to do with those exponents? Now you're not going to multiply them because that's not power to a power. You're going to add them. And be careful. Make sure you add 3 plus 1. Because even though there's no 1 there, it is x to the 1st power. So it's going to be negative 10x to the 4th power. Okay, this last one looks a little dicey. Let's take it slow on this one. So this one says x cubed y squared x y to the 8th power x squared y to the negative 8th power. All right. The first thing I notice when I look up here is I see one instance of a negative exponent. Where do I want to move negative exponents? Where do I want to move negative exponents? Think about the negative exponent property. Where do you move it? Remember the property was a to the negative nth power equals 1 over a to the power of n. So you want to move it across the fraction. Do you see a fraction here? No. So basically what you're going to do is you're going to rewrite all of that x cubed y squared times x y to the 8th power x squared all over y to the 8th power. So it gets its own denominator. It's the only one that's negative, so it's the only one moving. Does everyone see what I did there? Rewrote everything, just move the -1 to the bottom. Now, I get asked this a lot, so I want to make sure to let you know. If it's in the denominator and it's negative, where should it move? To the numerator. So always move across the fraction bar. Okay? Now, when I look at this, there's something jumping out at me. What's jumping out at my brain? Well, it's like, ah! There's a lot of x's, actually, right? But I see y to the 8th power and y to the 8th power. And y to the 8th power over y to the 8th power is going to be 1. So those are gone. Don't need them anymore. So now I have x cubed, y squared, x, and x squared. So it's short-lived, but we no longer have a denominator anymore. Now there's a lot of x's going on up there. I see x cubed, x, and x squared. How many x's is that? There are 6 of them. If you're confused on how we got 6, 3 plus 1 is 4. 4 plus 2 is 6. All right? And there's no more y's besides the y squared. So it's x to the 6th power, y squared. Now, this one got a little more challenging. We're going to do a few more on the next slide that get a little more challenging as well, with a lot of fractions. So let's do those, and then you'll have a chance to try some on your own. Any questions so far? Do you feel okay? Okay. All right, let's look at this one. A to the 5th power times b to the 4th power, and that's actually a b to the 7th power in the bottom. That's a b to the 7th power. Okay? This is similar to one we did on the previous slide. I prefer, it's my preference, to simplify in the parentheses. So do you see how I have b's on the top and the bottom? All right? Which one has more b's? The bottom by how many more? 3. So it's going to be a to the 5th power, didn't touch that, over b cubed. Still everything squared. Okay? Now each of these, the numerator and the denominator, needs to be squared. So we have a power to a power. The operation we do there is multiplication. So it's a to the 10th power over b to the 6th power. Questions on that one? Okay, 2 more. Now this next one has negative exponents. All right, we have m to the -3rd power in the numerator and n to the -4th power in the denominator. So where am I going to move those? Across the division bar, okay? Across the fraction bar. So I'm going to leave n to the 7th power up there, and I'm going to leave m squared down in the denominator. But I'm going to move n to the 4th power up top and m to the 3rd power in the bottom. And notice when I move them, they become positive. When I move them, they become positive exponents. I get students that do this every year that want to move everything. All right, I get students that move the ones that are already positive. Should you move the ones that are positive? Don't touch them. All right, just leave them alone. Now we have the n's and the m's in the same numerator denominator. So this is multiplication, n to the 7th times n to the 4th power. What am I going to do with those exponents? You're going to add them and get n to the 11th power over m to the 5th power. Questions on that one? Okay. Yeah.
So when do you know how to add or multiply?
When do you know how to add or multiply? Good question, Jennifer. How do we know when to add or multiply? Yes, Ashton. When you're doing, are you talking about negative exponents? No, sorry. Oh, if it's a fraction? No, sorry. Never mind? Okay. Yes, David? When your coefficients are multiplying, you add? Are you talking about your bases? Your bases, I got you. So like if we had 2 to the third power times 2 to the fifth power. So the bases are the same and we're multiplying. So you're going to add and get 2 to the eighth power. How do I know when to multiply? Thanks, David. How do I know when to multiply? Okay, so exponent. Excellent. So like a to the fourth power, all of that cubed. All right, that's exactly right. Really, when you see two instances of exponents, but the key thing that I always say is power to a power. Right? And then when you do that, you can say, I got the power! Okay? That's really fun. Try it. Everyone want to try it? No? Too early? Too early? Okay. Maybe tomorrow. Maybe tomorrow. Maybe tomorrow. All right, let's do the last one. 3 u to the fourth power, v to the fifth power, 7 v cubed u to the eighth power. No negative exponents in this one. So I don't need to like move anything up or down. So that's good. Do you guys see the 3 sevenths? 3 sevenths cannot simplify. What if that would have been 3 sixths? What if that would have been 3 over 6? Would I simplify 3 over 6? Yes, so if you can simplify the coefficients, please do. On this one, you weren't able to. So we're still going to have 3 over 7. Which letter do you want to start with, U or V? U, okay? Which one has more u's, u to the fourth power or u to the eighth power? U to the eighth power, right? So there's more in the bottom. How many more are in the bottom? 4. So there's going to be 4 in the bottom. Yes, Daniel. Well, hold on. Did I move it? Did I move it? Did I do that? I didn't move anything, right? I didn't like to move it there because I asked myself, which one has more u's? Which one has more u's? The bottom, right? 8 is bigger than 4. By how many more? 4 more. So I didn't move u to the fourth, even though it looks like I might have. All right? Now, if you wanted to move this, Daniel, if you want to move u to the fourth to the top, it would be u to the negative fourth power. But you should never leave any of these with negative exponents. It's not fully simplified if you have negative exponents.
So it always goes to the bottom, like whenever you, like.
Why do I don't want to say always goes on the bottom. Why did it go on the bottom here? Because there are more u's in the bottom. If there would have been more u's in the top, then there would have been u's in the top. I hear it. I'm going to finish. How many v's in the top? How many in the bottom? 5 and 3, right? Which one has more? Top by how many? 2. So we have v squared. Excellent. Excellent. Very good. Good job.